Hello everyone, I'm Maksim Siniukov. I'm going to present the DiTaiListener paper, Uncontrollable High-Fidelity Listener Video Generation using Diffusion. This work was done in Intelligent Human Perception Lab at UC ICT. Listener behavior generation task requires to generate a listener response to the speaker's cues, such as head motions, facial expressions, and voice. Existing listener behavior generation methods such as dyadic interaction modeling and L2L rely on low-dimensional motion codes, 3D morphable models, with limited expressiveness and visual realism. They work on short clips, causing fragmented transitions and poor long-term coherence. They often lack temporal causality between the cues and the reactions. The model generates the videos in two stages. At the first stage, called the DiTaiListener generator, we generate 4 seconds clips. In this stage, listener appearance is concatenated to the noisy latents to provide appearance guidance. Freeform text control is encoded via T5 and BERT text encoders. Speaker cues that are given to the model are speaker audio, encoded via WAV2VAC audio encoder, and speaker motions, encoded via Imoca 3D morphable model. Those features are passed to the Causal Temporal encoders. This way the model extracts only relevant information from 12 seconds features context window, and may only see the past, enforcing causality between speaker cues and model-generated listener response. Those features are then passed to the diffusion model via CTM-Adapter. The purpose of the adapter is to merge 3 different modalities: speech, text, and motion, and assure causality. Let's take a look at the speech modality branch. Queries of the video are concatenated to the queries of the speech. The same is done for keys and values. Then self-attention with causal mask is applied to get tokens. The same is done for motion and text condition branches. We do element-wise sum of tokens gotten from all branches to merge all the modalities. The model is trained with diffusion loss on 115 hours of conversations from real-time data. As a result of the first stage, we generate 4 seconds clips. On the second stage, we generate transitions between those clips. Edit model is conditioned on the listener appearance and 2 frames, one from previous clip and one from the next one. The model generates frames in between to ensure video consistency. This way, the model may generate long videos. Here are the results of video generation.
Working with a child actor, because I believe the actress, her birthday was today, Margaret told me. Riley, you guys were so sweet on set. How was it working? Like, was there any challenges? Was it fun?
Our model generates more diverse and coherent videos. We also compare long video generation with prior approaches, prompt travel and teacher forcing.
Whatever, but it's something that I'm feeling that I haven't, it's just an intense feeling that I have, and that's what comes to my tongue when I see you, when I say goodbye to you, when I don't know.
Let's pause and see several consecutive frames, generated by our method and prior methods. We may notice that teacher forcing method accumulates errors, while prompt travel creates blurry images at the transitions, while our method creates sharp and consistent videos. Our model achieves state-of-the-art photorealism on real-talk dataset, proved by marginal improvement in fetched image distance, fetched video distance, and LPAPS image quality metric. We also achieve marginal improvement in generation quality measured in 3DMM Imoca space. For user study, we asked 50 participants from crowdsourcing platform to evaluate the quality of the listeners generated by different methods on the Vega dataset. We asked participants whether the response from the listener provides correct feedback to the speaker, whether the head motions and facial expressions are diverse, whether the general video quality is flawless and smooth. The user studies show that the most users selected our model output as the best one across all scales: feedback, diversity, and smoothness. We show that our model works for out-of-domain generation. We may also use text condition to guide the model with emotional context of the conversation in the free form.
When you first told me you loved me.
In conclusion, we introduced pixel space video diffusion model for listener response generation, achieving 73% improvement in photorealism. Proposed DiTaiListener-Edit, coherent long video generation method. Introduced CTM-Adapter for diffusion transformer that allows controllable face generation and aligns listeners' responses with speakers' cues. Demonstrates the potential of video generation methods for social intelligent, coordinated and controlled face and head gestures. Allowed freeform text control to guide the listener's behaviors.